Hello, Coach Holmes here, and today we're going to be talking about chords in a circle and what they actually mean when they relate to one another. So one of the biggest things is we got to know our definitions, and one of the definitions is inscribed. Basically, it's a figure inside of another geometric figure. So for example, this quadrilateral ABCD, that's an inscribed figure because it's inside a circle, which is a geometric shape. Now it could be inside, now it could actually be inside of a triangle, it could actually be inside of a hectagon, a pentagon, whatever the case may be, as long as it's inside with all the vertices touching one, at least with all the vertices touching a side. Now, circumscribed is a circle that touches all vertices. So it's this circle right here. This circle is what we described as circumscribed. Let me rewrite that. While the figure itself, the quadrilateral, is inscribed. Okay? So that's the big difference between the two. Circumscribed is the circle that has a figure inside. Inscribed is the figure that is inside. And it could be any sort of shape. It just happens to be a quadrilateral in this case. Next, we have theorems that actually helps us to find the arc. So for example, two minor arcs are congruent if and only if the corresponding chords are congruent. So what does that actually mean? Well, if I have two minor arcs here, I have these two arcs. The arc measures are the same as long as the chords are congruent. If both chords are congruent, then the arcs, both arcs are going to be congruent as well, and vice versa. So it works out both ways. Now, we do have a theorem when it comes to perpendicular. If a diameter or radius is perpendicular to a chord, both chord and the arc are bisected. So what does that actually mean exactly? Well, let's look at this figure right here. So notice I have a radius here and I have a chord. So what does that actually mean? Well, the chord is actually bisected as well as the arc itself. Now, of course, I'm not putting the intention to show that the length are the same, which is actually true as well, but I just basically want to show that the angles are the same. Okay? So for example, if HP is 12 and the arc HP is 134, we want to find arc HE and find OS. So we want to find this length right here as well as that arc. Okay? So I know that Y is at least half of 134. at least that angle is half. So if I divide 34 by 2, I get 67. So the arc HE is 67 degrees. But now I want to find OS. And oh, by the way, I want to say the radius. Forgot to put this in there. The radius is 13. I forgot to mention that. So the radius is 13. So I know that this length right here is 13. Well, what does that mean about HS? Well, HS is half of HP, which we know that to be 24. So the HS is going to be 12. 12 here, 12 there. Now, notice that I have a right triangle. So I can use Pythagorean theorem to find that third length. So I can say x squared plus 12 squared equals 13 squared. I know 12 squared is 144, 13 squared is 169. Subtract 144 from both sides. X squared equals 25. Square root that. That gives me x equals 5. So OS is going to equal to 5. Okay? So that's how I'll be able to find the length OS. As long as I know what these two lengths are, I should be able to find my third length, or this OS. So it is knowing, so part of it is actually knowing what you have, okay? That's the biggest thing we gotta keep in mind. We gotta know what we have. Now, going back to this problem here, this new problem. So AB is 30, CD is 30, and CZ, the arc, is 40. So we want to be able to find these 8, which is going to actually be pretty, which if you really look at it, it's going to be pretty simple. Well, I know that it's perpendicular, so I know these are bisected. And oh, by the way, they both happen to be the same. So I know that, so half of 30 is 15. So AM is 15. Which I also know that because they're the same, MB is going to be 15 as well. Well, what about CN? Well, that's 15. And ND is 15 again, because they're both congruent. Now, so since both arcs happens to be both chords happen to be the same, then I know the arcs are going to be the same. So if I know ZZ is 40 degrees, I know DZ has to be 40 as well. So what does that mean about CD? Well, that's 80. Since I know this whole thing is 80, I know AB, this whole thing is 80. And to find YB here, I know it has to be half 80. So that's going to give me 40 degrees. So the biggest thing we got to remember is that when we have two chords, as long as they're congruent, the arcs are going to be congruent as well. But also, if we have a perpendicular, if we have a diameter or a radius perpendicular to the chord, it bisects both the chord and the arc. Thank you and have a good day.